Have you ever wondered how your computer can run multiple apps at once? If you were to make an educated guess, it would probably be with CPU cores. Most modern CPUs have multiple smaller CPUs within them that can compute in parallel with each other, which we know as cores. Modern consumer computers can have anywhere from 4 to 128 cores, so if we were to have each core compute a single app, then we can run more than one app at once. But here's a little problem. What if we wanted to run more apps than we had cores, or what if we only had one core? You might recall from 1521 that all code is compiled down to just a series of ones and zeros. But how does this help us run things in parallel given the restriction of one core? One idea is that we could take all the machine code we want to run in parallel and have them take turns to be executed, effectively scheduling each process to be ran for a certain amount of time before switching to a different process and back. That's the fundamental idea behind the scheduler. In our example, let's have our scheduler alternate between two programs every 5 instruction cycles. In our first program, we add 10 ones together and print the output, and in our second program, we multiply 2 5 times. There is a caveat though. Our CPU has to share the same registers and stack across different scheduled programs. So we need a way to store and load the state of the current program before switching to the other program. Here we can see that even though we execute the multiplier after our adder has written changes to the registers T0 and T1, our scheduler is able to store the state before the multiplier was called, and restoring that state after multiplier was called makes it seem as if the multiplier process never existed in the first place. Using this technique, we can run as many processes as we want at once. Since modern CPUs are so fast, the pause in between is negligible to the human eye, which makes it seem as if we're running multiple programs without issues.